Assalamu'alaikum Warahmatullahi Wabarakatuh. Hello everyone, my name is Hafidhoh Kamalatul Iffah from Chemistry Education, Win Wali Songo, Semarang. In this video, I want to presentation about how to make ammonia produced on an industrial scale. You have likely produced ammonia in the laboratory from the thermal decomposition of ammonium chloride or from the reaction of ammonium and hydroxide ions. Have you ever wondered how ammonia is produced on an industrial scale? In this lesson, we will learn about the Haber process to produce ammonia, developed during World War I by Fritz Haber and Karl Bosch. For their efforts and contribution to develop large-scale industrial processes, they were awarded with Nobel Prizes in chemistry. The Haber process is the industrial process for the manufacture of ammonia from hydrogen and nitrogen. Hydrogen is obtained from the reaction of methane and steam produce carbon monoxide as a byproduct. The hydrogen produced from this reaction also reacts with oxygen from air, producing water and leaving nitrogen behind. Recall that air is 77% nitrogen. These gases are then compressed and delivered to the reactor where ammonia is produced. These gases are then cooled down and ammonia is liquefied, ready to be tapped off. The Haber process uses the Cutler's principle to maximize ammonia production, while keeping operating and production costs in mind. The Cutler principle tells us that increasing pressure will favor the sites with fewer moles. For our case, the production of ammonia, it would make sense to conduct the reaction at a very high pressure. But we must also remember that it is expensive to build and operate a plant that can withstand such high pressures. Therefore, a compromised pressure of 200 atmospheres is used. The forward reaction is exothermic. It would make sense to conduct this reaction at a low temperature. The compromised temperature is 400 to 500 degrees Celsius, which is not exactly low but not too high. If a low temperature were used, the rate of reaction would be very slow, so the exothermic reaction would be favored. It would actually take a long time for equilibrium to be reached. So a compromised temperature of 400 to 500 degrees Celsius ensures that the reaction progresses with sufficient yield. The yield of the process is 10 to 20%. In conclusion, the Haber process is the industrial process to produce ammonia from hydrogen and nitrogen. It is conducted at 400 to 500 degrees Celsius and at 200 atmospheres.